Hey folks, welcome to chapter 2 of our textbook. Yay! It's going to be a pretty quick chapter. We're going to talk about something called rational expressions. Now, rational expressions look awful, but their bark is much worse than their bite, meaning that they are not as bad as they seem. They're going to be building on a lot of the factoring that we've seen in the first chapter. So I'm also going to include with this assignment that factoring flowchart and some helpful ideas on how to look at it with factoring. Today we're just simplifying it. You're going to watch the Delta Math, then you're going to do the Delta Math problem sets, you're going to do the summary, and then you got a reading survey for next time. Without any further ado, let's go for it. We're going to start off with some vocabulary. Well, our goal is to simplify a rational expression, so it helps to know what a rational expression is. And it's just the quotient, remember, this is division, of two polynomials. It's just a fraction made of polynomials. And you can have a polynomial that has many terms or just one term. Either way, it's still a rational expression. And you might remember this idea of rational numbers from when you talk about fractions. They were rational. Now, talking about fractions, let's talk about a blast from the past. Woo! Now, you've simplified fractions before with no variables. There are two examples down here. And the steps were just to factor the numerator and denominator, and then cancel factors present in both. Well, let's just show what I mean by that. We're going to do the exact same thing with our rational expressions with polynomials. Well, 21 is just equal to 3 times 7. 27 is equal to 3 times 3 times 3. I factored it as much as I could. So, boom, done. I need to cancel factors present in both the numerator and denominator. That's just 3 and 3. So last but not least, we just combine everything back together. We say 7, and you know what? For our purposes today, I'm just going to leave it as 3 times 3, because that's what we're going to do with the polynomials. Now, same deal with the second one. We need to factor the numerator and denominator as much as we can. So that's just going to be 5 times 5. And 50 is just going to be 5 times 2 times 5. That's factored. Now, because we're multiplying everything in the numerator and denominator, the order doesn't matter. So that's fine. If in the denominator you had instead written 2 times 5 times 5, perfectly fine. So first step is done. Now we need to cancel factors present in both the numerator and the denominator. Here it's 5s. Now we're only canceling out things that have pairs. Now there is a second 5 in the numerator. There is a second 5 here. So I can also cancel that stuff out. That also cancels. Now I've canceled everything in my numerator. You might be tempted to put a 0. We can't do that. If you cancel everything out, 5 divided by 5 is 1. 5 divided by 5 is 1. There's just a 1 left. And my denominator is just 2. So that's my simplified fraction, or my simplified rational expression. So we've done it. And we can have multiple factors cancel out. You can also cancel in different ways. Some of you may have said, well, that's just 25 over 2 times 25 and cancel that. Perfectly fine. Also acceptable. Now, let's see how we're going to do it with polynomials. It's the same thing. We still factor and we still cancel. So let's take a look at it with number 1. Now, obviously the more difficult thing is here, we're factoring using something other than just breaking it down with a number tree. For instance, this numerator is difference of perfect squares. It's going to be x plus 4 and x minus 4. This denominator is not difference of perfect squares. It doesn't have a subtraction symbol. It's just going to be GCF. I can take x out of both of them, and I'm left with x plus 4. Cool. I've factored that as much as I can. Now I need to cancel things out that are in both the numerator and the denominator. So if I'm looking through this, I see that there's an x plus 4 and an x plus 4. I can cancel those out. They're going to cancel out entirely. And I'm just going to rewrite what's left. My numerator has x minus 4. My denominator has x. You'll notice that in this second bit, like here I had parentheses, here I didn't have parentheses. You only need the parentheses if the factor is next to something it's multiplying. So I didn't include it in my last step just because they're unnecessary. They're meant to show that it's a group and that it's separate, but here, there's nothing to be separate from, so I don't need them. Let's try the second one. For this second one, that top one is going to be factors and sums. So that's going to be numbers that multiply to 18 and add up to 11. They're all positive, so that's nice. It's going to be x plus 9 and x plus 2. Cool. Now my denominator, that's going to be GCF as well. I can pull out x to the third power there. If I take away 3 x's there, I'm left with 1. I take away 3 x's there, I'm just left with 9. Cool. I've factored as much as I can. Now I'm going to look for factors that are present in the numerator and the denominator. And I realize that x plus 9 is present in both. So I can cancel those out. And what's going to be left over here is x plus 2 and x to the third. That's our final answer. Now, let's check out how to do it on Desmos. It's always nice to be able to check your work, and you've been able to check your work in the past by seeing if this fraction gave you the same decimal as this fraction. I mean, you could just go to Google Calculator and say 21 divided by 27, hit enter. It gives you that weird decimal. And then I can also just go to 7 over 3 times 3, divided by parenthesis, 3 times 3. It gives me the same weird decimal. It's nice to be able to check if you're right. We can do that with Desmos as well. I can just enter a fraction, and there are 2 ways to do it. I can either do parenthesis, x squared minus 16. Make sure it's in the parenthesis. Divided by, and it automatically puts in a fraction, x squared plus 4x. Make sure you're in the fraction's denominator. It gives you that. Now I'm going to enter our simplified version, x minus 4 divided by x. I just hit slash first, and I said x minus 4 divided by x. These are the same graph. If I turn one off, I can see that they overlap each other completely. And that's exactly what we're looking for. We want them to overlap each other completely. We can do it with the second one as well. I'm going to do that one just a bit faster. We can also see that they overlap each other completely, giving us a wonderful, wonderful way to check. One thing before we move on, and this is a major pitfall that gets everyone, and you need to watch out for it. What I'm about to show you is wrong. Don't do it. You cannot do this. Oh, there's an x squared and an x squared. I'll cancel them. And that'll just bring down everything else. That is wrong. That is like saying, oh, I had 71 over 7. I'm going to cancel the 7s and my answer is 1. These are wrong. You cannot do that because you're not factoring it completely first. Because this x squared up here is part of a larger polynomial. It's combined with addition or subtraction. You can't just cancel out the x squareds. You can only cancel something if, like in our previous examples, it was combined with multiplication. These were multiplied together. These were multiplied together. Let's get rid of that. These were multiplied together. These were multiplied together. That's why we could cancel them. And in fact, you have been doing it for some time. These were multiplied. These were multiplied. These were multiplied. These were multiplied. Because they're being multiplied, you can cancel them. But because these are not being multiplied, you cannot cancel them. As unsatisfying as it may seem, this example up here is already as simplified as it can be. I can't do anything here. Because if I factor out, I'm going to get x minus 5, x plus 1, and I can't factor the denominator. And there are no factors up here to cancel. That is its most simplified form. Cool, you have seen how to simplify them by first factoring and then canceling. Make sure you're not falling for that pitfall I mentioned at the end. It's very common and it's very wrong. You can make sure you're not falling for it by checking using Desmos or another graphing software. It'll just make sure that you're good to go. So, you've completed the video? Yay! Head on over and do those Delta Math problem sets. Then you got a summary and a reading survey. Don't forget about those. If you have any questions, see me in office hours, folks. Have a great day.